Please welcome our moderator, and that is, over to you.
Thank you. So I'll start from here. I'll just get my notes. Perfect. Okay, thank you. And thank you to Frank and the organization to suggest me as a moderator for this session. And thanks for the great introductions that were done from Jan, Peter, and Frank. I think that put us in a very nice place to sort of the big picture and how things are evolving. And of course, good that we have been introduced to that working paper, which is our sort of task of the days to fill in blanks and to further develop it. So I really hope people can provide comments, can come up with perspectives that are important from their perspectives. And of course, now we are starting with the sort of fundamentals, the physical science. But I want you to focus on how the physical science can act as bridges to the solution side and to both challenges and barriers and opportunities, of course, and try to picture it in that way, to always bridge to other sciences and other things that are policy relevant. That would be great. So I think we will start with a presentation from Piers Forster, from a professor at Physical Climate Change at the University of Leeds, also director of the Priestley Center for Climate Futures, also at the University of Leeds, I think. A long-time record as an IPCC author. I think you have been engaged in the 4th, 5th, and the 6th assessment report. We as Focal Points have had the pleasure of challenging you with both easy and difficult questions during that process and made our review comments. And of course, you also have an extremely important role as interim chair for the UK Climate Change Committee since 2023, and also been a member of that committee since 2019. So Piers, please welcome, and I think we will have a presentation on screen somehow.
Cheers, Ollie. Good to be here.
Yeah, thanks.
Excellent job.
And I'll try to throw it as
friendly
friendly as possible when I get challenged to do that.
I'm just trying away from my slides. No, they're not my slides, they're Piers' slides. Not Piers Wittgenstein, Piers Forster. We're almost the same, but he's kind of Belgian and I'm English.
Confused many times with
Piers
and Piers.
Well, we always turn up in the same location and we're almost interchangeable. So good morning, everyone. I think it's really interesting to think of how, just as Ole said in the introduction, what we can learn from the physical sciences about where we are currently and what we have to do to decarbonize. And this is an annual project we started 2 years ago, where a whole lot of us as long-standing IPCC authors, these are 55 authors from 44 institutions, a lot of them in the EU, did want to come together because we were quite frustrated that the IPCC, although being this really authoritative document, was not updated often enough. And in particular, we're in a really significant decade where we expect temperatures to go past 1.5 degrees, where we expect greenhouse gases to peak and decline, and we have to have an authoritative way of monitoring these changes. And quite a lot of people, I've been involved in the COP negotiations, and if you're in those COP negotiations, a lot of publications come out before, and I don't know if that'd be good to understand from the negotiators that are with us today. But I think from my perspective, what comes out before can be quite confusing, you know, because you get contradictory kind of reports, and they can often confuse or perhaps destabilize some of the important negotiations. So what we try to do with it, we try to be, this is what the IPCC would have said if it was published today. I go on with this, don't I? Hello. Yeah, okay. So what we try and do, we try and track a set of indicators that go from the left to right on the diagram. They go from greenhouse gas emissions to greenhouse gas concentrations to the radiative forcing to the energy balance changing to the observed temperature changes to the human-induced temperatures, and then to some extremes. And unfortunately, if you look at the direction of change for all these indicators, they are going in the wrong direction. So they have all increased substantially, and the only one that has decreased is the one you don't want to decrease, which is the remaining carbon budget for 1.5 degrees. Is significantly tinier than it was since the very last IPCC report was produced. And the headline from this work, published in June, was that we're seeing unprecedented rates of warming currently, and the 1.5 degree remaining carbon budget that Pierre will pick up on in his kind of presentation is now down to 200 billion tons for a 50% chance of keeping temperatures below 1.5. And just as Carlo talked about, I have 2 jobs, so this is why I'm not wearing a tie, because I'm a kind of scientist, but I'm kind of wearing a smart suit and shirt because I'm also a bit of a politician. So I currently chair the UK Climate Change Committee, and two days ago we did produce our recommended advice for the 2035 NDC, which was a 81% reduction by 2035. And in reference to Peter's comment, he just walked in, when he was talking about advice from the European Advisory Council on the energy transition in EU countries, the UK committee works a bit differently. Yes, we have scientists on board the committee, like I am one, but we also have politicians in the committee and economists. So a big part of our advice to the UK government is to try and make sure when we give our NDC advice, we have just given. We try and make sure that it is really politically deliverable. So we have that very, very, very tight connection to the politics in our country and to the politicians. And in fact, I did personally find giving the NDC advice quite challenging this time, because we were expressly asked by the Prime Minister to give an NDC recommendation that was compatible with keeping temperatures below 1.5 degrees. And for myself as a scientist, when we're so close to that 1.5 degree target, that's almost impossible to say to the kind of PM, oh, don't worry, yes, this 81% is compatible with 1.5 degree target. But we did try and incorporate it into our advice, but it's getting increasingly challenging to come up with a deliverable NDC recommendation that is compatible with keeping temperatures to that 1.5 degree extreme. Yeah, okay. So I talk about this. So I won't take you through everything we produced in the cater work, but we can talk about it afterwards. The whole point was to be authoritative, to be up to date, to be internationally respected by negotiators from different countries, right, like the IPCC, and our particular target for this report we produce annually for this publication is to really target the technical side of the COP negotiations, so we don't target the December political COP. We produce this publication just before the technical dialogues. Okay, just to show you where we're going to currently. So the whole point compared to the carbon budget or something with the report is to try and be comprehensive. So we don't just look at carbon dioxide, we look at all greenhouse gases, including the F gases, and there was the first inkling that when you look at all greenhouse gases, they are beginning to peak now, because we haven't quite got up to where we were before the pandemic, and there is a hint that perhaps they're changing, but it is still too early. But I just got back from 2 weeks in China, in fact, talking to their government, and it's interesting to see what's going on there. They are in fact about to adopt a carbon budget approach, like we've got in the UK. So they were interested in how it worked, and they were suggesting that they could probably peak emissions in the next couple of years or even earlier. So it's quite interesting. Yeah, so we do track the concentrations, and you can see from this graph they're going in the wrong direction. And what we also have a look at are the short-lived pollutants as well. They look at them, and we try and put the different constraints together to work out what the IPCC would have considered an increase in effective radiative pulsing, and we do the combined effect of the greenhouse gases with the effect of aerosol pollutants as well. There was a lot of controversy last year and question last year: what is the role of shipping pollution, and could the decrease in pollution from shipping possibly really affected the ocean temperatures and potentially affected that big increase in temperature we've observed. And the analysis we put together was quite interesting because it indicated that we would have expected an increase in temperature to come from that decreased pollution from shipping because of the regulations, but in fact that was almost directly counteracted by an increase in pollution from wildfires in Canada that did also occur. So I do guess if you try and look for an easy explanation of why 2023 and 2024 have been such high temperatures, there is not that one simple explanation. The answer is going to be complicated, and the whole point of this overall assessment we're trying to do with this work is to really try and get all those different components, to try and get all those components together, to try and make a really comprehensive understanding of what is going on. And a big concern of course is all this extra energy that's going into the Earth system currently, that is heating the ocean, and that it is kind of melting the ice. So this is something we track over time, and if you look at the pink, red bars on the right-hand side of the diagram, this does show our estimate of the current energy imbalance, and you can see where we are currently. We have an excess imbalance of about 1 watt per meter squared currently. So what that telling us is for every square meter of the Earth's surface, there is an extra watt per meter squared of energy that is going into heating the overall system. And of course, this is causing the temperature to go up. So what we try and do in this report is to try and get all these bits of information together to try and work out the current human-induced contribution to surface temperature change. And this is an important thing to understand, because this human-induced contribution is enshrined in the UNFCCC 1992 agreement, because it tries to look for the anthropogenic effects on climate change. So you can see that with our assessment, the actual observed surface temperature does sometimes go above the human-induced contribution, and it sometimes drops down below it. And our assessment is that currently the human-induced component is about 1.3 degrees. So that is considerably below the observed temperature change, which is about 1.5 degrees currently. So, but but then if you look over a longer term time, like a decade, the human-induced estimate of temperature change and the observed temperature change, they are practically equal to each other. I'll have to end then. I did have more slides, but things seem to stall. So perhaps I'll conclude. Oh no. Yeah. So I have a slide. Is that yeah? I have one slide. So there's a lot of interest in this remaining carbon budget to 1.5, and the issue is that the closer you get to 1.5 degrees, this remaining carbon budget becomes a more uncertain calculation, and so you have to have an uncertainty, and there are some issues to understand. You have to understand that you exhaust the remaining carbon budget before you actually do go past 1.5 degrees. So there are some complicated things in explaining it and communicating it. But I don't want to take you into uncertainty. So if you want a kind of 50% chance, then you're at 200 billion tons. If you're comfortable with only a 33% chance, then it goes up to 300 billion. And if you want a 67% chance, then it decreases. And what we tried to do to communicate this work was to try and put the quantities all on a very easily accessible dashboard. But I think it would be interesting to get a discussion today about really kind of what is the very best way of communicating these indicators that really supports your work with your governments. So we do basically want some cash to continue this work. So please
dig deep,
cough up. Yeah. I will be coming around next one. This work has got a lot of interest, kind of coming from the kind of scientific community, and a lot of my colleagues do want to join in. So we're going to kick off these kind of parallel work, looking at sea level and looking at precipitation. Yeah. Okay. I think I'll stop there. I probably talked for too long. Okay.
No, but it's fine, Piers. I think that was very comprehensive. And I think, first of all, we are extremely grateful of the scientists that are doing this on an annual basis, and also the way you actually do it, because what you do is to sort of reassure us that the methodology used in the AR6 report was comprehensive. But of course, as you and others, we are always in that situation where the numbers from the IPCC reports are getting sort of outdated quite quickly. So I think for us as a negotiator and also as an IPCC focal point, this is very well appreciated, because it both sort of anchors the methodologies that has been used, but also provide new and updated numbers for us to use in our work. I want to open the room for short clarifying questions, if anybody has something they reacted on and want to sort of pick up right away. Okay, I'll try. Yeah, you'll be my first victim. Are you ready? He's ready.
Okay, thanks, Piers, and that was fascinating. Really great. I suppose a lot of questions. I'll just try to contain myself in terms of those. Just on the carbon budgets, that's a CO2 budget. I was just wondering, how is that impacted by the non-CO2 greenhouse gases, and how is that factored into your calculation? Or is that something I should be asking?
No, you should ask me that bit.
Okay. Then on that global temperature increase, how can we relate? I mean, even the AR6, I suppose it was different to the AR5, and the Paris Agreement, the global temperature there is an AR5. It's based on the AR5 analysis. So can we compare what you're doing with what governments signed up to? And that's a bit of a political question.
Yeah.
And then the final political question. Global Stocktake said the energy transformation, we have to do that, get fossil fuels out of the energy system. Has that impacted in the UK Climate Change Committee, or do they respond to that?
Yeah, okay, well, that's good questions. So I'll ask them, or shall we get a whole lot of different questions first?
I'll come over to you. I'm polite with you.
You don't have to throw it. You've got to throw it.
Yeah, I'll throw it harder next time.
Throw it hard in the head.
Yeah, good morning. Christiane Textor from Germany, and I'm also working with the IPCC and for the convention, so in both contexts. My question is about the uncertainties, the ranges of the budgets. Is it included in your probabilities? First question, very easy. And the other one, there's a lot of discussion around the feasibility of 1.5, keep warming 1.5 within reach, and it's too late. And so if you, on the one hand, there is this hectics, and on the other hand, we know that climate change, 30 years, decades, it's a slow process. So with your indicators, you are sort of feeding into this hectical discussion. So how?
I don't want to feed into that.
I know that. So how do you avoid? That's the question.
Yeah,
I know that you don't want.
Yeah. Well, that's interesting. Okay, I would find that a lot of different questions for way different angles. So should I answer the kind of technical ones?
Yeah, go ahead with those.
Okay, the technical one, the Frank, yes, that carbon budget, that remaining carbon budget is just for carbon dioxide, but so therefore we have to come up with an assumed projection for the temperature change for the non-CO2 components, and that is exactly why the remaining carbon budget does run out before you pass that 1.5 degree target, just because there's an extra contribution to temperature that comes from those non-CO2 bits. And in terms of the uncertainty, yes, we do try and take into account the uncertainties, and we try and especially do them exactly the same sort of way that they were done within the very last IPCC report. Frank asked another question, which he asked about the Climate Change Committee work and the NDC, and we asked about the feasibility of 1.5, and those two things are sort of related a little bit. I sort of think, just because if you look at the text of the GST text, or you look at the Paris Agreement precise wording, there is not a precise technical definition of the temperature increase of 1.5 degrees there. But there are some important things to understand. The first thing is there's not two temperature goals. There's not a 1.5 degrees temperature goal, and there's not a 2 degree temperature goal. If you look at the wording of the Paris Agreement, it to keep temperature increases to well below 2 degrees and pursue efforts for 1.5 degrees. But then you have the GST text that want more than 1.5 degree of that, and you have slightly different ways of defining it. And what I would say, the quantity we're producing in this indicator publication, that 1.3 degree number, I put up with that. That is more or less consistent with the way it was defined within the AR5 report. There are slight differences. It could be 0.04, 0.03 degrees perhaps, just from the technical changes, but that is pretty much consistent with the way it was defined in the AR5 report. So that says we're about 0.2 degrees off from when the authors of the AR5 report, or from when the Paris Agreement was first defined. But we have to understand, as the speaker said at the beginning, that the impacts of climate change are now a lot worse. So we're kind of, when the negotiators did have a perception of what 1.5 degrees implied in terms of the impacts, I think we now understand today that the impacts of 1.5 are a lot worse than people thought at that particular time. So that is the whole point, I think, in why we have to keep 1.5 there on the table. But to get to your point, Christine, what I think we need to do with these annual updates, we have to just make it a constant drumbeat in some way, a constant drumbeat of this is where things are going, and perhaps when the greenhouse gas emissions start to decline and things do start to change, perhaps we will see things improve. But we have to tell the negotiators the actual climate system we all care about and we're impacted by, that is still getting worse, you know. Despite your efforts to build renewables and all these other things and do the adaptation, the actual climate impact, the actual temperatures are still getting worse and worse. And I think we have to tell the negotiators that every single year in a consistent way. So I think it's important we do that. But I just think, and some of this your JPI could do, is I think the community are aware of it too. I'm working with a WMO task team, in fact, currently, to really think about what that 1.5 degree target is and to try and communicate that more effectively. I think it's a good story. And I think we do need a good explanation that relates the political 1.5 degrees, we can never die. In terms of the political 1.5 degree goal, I don't think that can ever die, or we don't want it to ever die. But in terms of the actual temperature change, we are almost certainly going to go past 1.5 degrees in the next 10 years. So I think we do need a good way of communicating the two.
No, thank you. Thank you, Piers. A quick follow-up on that? Yeah, so Peter.
Okay, thank you. Thank you very much, Professor. I had one question about what you mentioned in passing, that you were in China recently and you were discussing with them methodologies, I guess, to develop their own approach to carbon budgeting.
Yeah.
Do you have any more information you can share on that?
I have a little bit, yeah.
How far is this, is this connected politically already? Are they looking at trajectories that are consistent with 1.5, things like that? Is it connected already to the new NDC? China will also have to submit in the course of early next year.
I can talk about it. I can probably say quite a lot more if you gave me like glass or confine, but what I can say publicly is that they did publish a high level government document in August that said they do intend to bring in the carbon budget approach in their 5-year plan, their kind of 15th 5-year plan. We go from 2030 to 2035, and they want to decide on the way to do it by next March. So there is a kind of window of opportunity to engage with them currently. And what can I say publicly? And there's a lot of interest in that first carbon budget, because that first carbon budget will basically define at what level they keep their emissions, and it will also set their next NDC as well. Yeah, so whatever they decide on that first carbon budget will be very interesting. And I can talk a bit more about it afterwards, perhaps.
Perfect, Piers. And I also had China in capital letters in my notes, so that's good. Thank you for asking that question. Frank?
Just a quick one, and going back more technical, and you mentioned the aerosol issue, and obviously this sort of nonsense about shipping causing the
nonsense. It's not completely.
It's not complete nonsense, but it's certainly, how should I put it? It's, if you take it in the context of sort of long-term air quality policy to take sulfates out of the atmosphere in Europe and North America, it's small, I would say. And
it is small.
And but also you mentioned the wildfires in Canada, which were more extreme than ever recently. So that still is the major uncertainty in understanding the energy imbalance. Do you think we'll be able to solve it in the next, or reduce the uncertainty around that significantly in the next year or so? I'm thinking about what can we do for 2026 on that, and how important is that, do you think?
Oh, I do think it's important, but I do think we don't have to exaggerate the importance of the aerosol effect either. I mean, that becomes more important in uncertainty terms for these 1.5 degree trajectories, but just as Karen said this morning, I think he's probably going to do something else. But just as he said this morning, that isn't where we are currently. When we aren't going for the 1.5 trajectory now. If you look at where the NDCs are currently, they're all going to 3 degrees or there and thereabouts. So and within those trajectories, the uncertainty does really come from, can we see the big changes in the energy transition? That's more important than the kind of aerosol effects.
Well, thank you, Piers. And so I think What do we want to do now? Do we want to have a look at the key messages in this section of the review paper, if that is possible?
Yeah, please,
Yeah, so just to show you what's in there now on the screen. Excuse me?
The Q. I don't know what the cube. I don't know what is.
This one.
No, the Q. I don't understand what we do.
No, me neither. No, that's fine.
Did you ask something about the climate change committee? Did you ask something about the
We have it.
climate change committee? Oh yeah, you asked it. Well, that occurs. You can say, yeah, we absolutely. When we did give our NDC advice to government, we did consider the UAE consensus and what was asked for in the GST document. Yeah, we did consider the tripling of renewable energy and things.
Page 5. This 4. Yeah.
Yeah, so these are the indicative messages that goes to the opening section, or is this to the whole report?
the opening section.
The opening section. So we have influence of global warming in the first one, and how that does with slow onset and extreme weather. And then we have the annual global update of the annual global temperature. How it relates to the Paris Agreement and the connection to 1.5 limit. And then we have carbon dioxide, methane, and N2O, which we also will come in the next session.
But the question is, Piers, should we add something in here about the carbon budget, I think?
Or perhaps that could come afterwards too. I mean, that ought to be in the document, but it doesn't have to be here.
Yeah, and these are the indicative sort of key messages, and there are a lot of more information in the sections that are coming below.
Yeah. No, thank you for highlighting this again. What we want to do is to get key messages from each section. Those are just indicative messages that we drafted as part of the report. What we'd like to do is have a discussion with you either here or later, but by the end of this meeting to be able to firm those up and say those are the messages that we see as coming from this particular event. So I think what we can do now, I suppose, is to, we have printouts of those, so it's easier for people to read them. And what we'll do is let people look at them, and we can come back to them later on. We will come back to them at the end of the whole event and just make sure people are happy with them. So, Piers, I know you haven't read these, so I'll not put you on the spot.
I'm quick, Frank. If you have 100 different exams to kind of park in one afternoon, Frank, you do get quite good at looking at documents fast.
Okay.
The challenge is accepted.
Yeah, okay. Right. Okay. Is Carlo online?
Yes, I think.
Oh, good. Okay.
Yeah.
In that case, I ought to going to shut up now.
Great.
It stays there.
Okay, thank you. So what's the next one now? Carlo is coming. There, Carlo is. That's good. Thank you. Oh, that's... Is still... Yeah, now it's better. Thank you, Carlo. And I have understood that you are following us from online, as we see, and that you're on travel, but we are very grateful, of course, that you can provide us with input here. Carlo is affiliated with the European Centre for Medium Range Weather Forecast. He's the well-recognized director of the Copernicus Climate Change Service, the C3S. And of course, C3S is an extremely central node when it comes to generating climate data. And of course, also how such data can be presented and used by decision and policymakers. And that is policymakers on a very diverse set of levels, national, subnational, local, both public and private actors are interested in the data that are produced here. And of course, Carlo has also a background doing a lot of regional modeling, both within Europe but also outside Europe. So Carlo, please take us through your presentation, and we will surely get some questions from the audience afterwards. So please go ahead.
Thank you. Thank you very much. I hope you can hear me fine with no echo and you can see my slide. Thank you for the invitation. It's a real pity I cannot make it today, and so I cannot be with you in person, but I was keen to intervene even if only remotely. And one of the reasons why, or the main reason why I'm not with you is that at C3S, Copernicus Climate Change Service, we really try to cover the full set of climate data. So observation from the past, reanalysis for a near present climate condition, seasonal forecast and climate projections. And in particular on climate projections, we are currently doing quite a bit. One of the things we have done has been the operationalization, for lack of a better word, of the IPCC Atlas on the Copernicus interface. So there is more data, more functionalities, and the data is up to date, so it's not frozen as it is for the IPCC. And I put it here at the beginning. I won't be talking about projections. I will be talking about the state of the climate today. But the reason why I'm not with you is that we are working with ESA at the moment in try to scan the horizon on what can be done on climate forcing in terms of operationalizing the forcing data that gets into climate projections. So the idea, and Piers, I hope will join us later in the week to look at that as well. So being the host, I thought it was unfair not to be at the CNWF for this event. But what I will be talking about today is mostly to do with observation, and in particular to the operationalization of climate information coming from observation and reanalysis. And this is clearly linked to what was presented in the introductions, because there is the big discussion, and Piers is a very eloquent speaker about the big discussion about mitigation and carbon budget. But as the introduction or introductory speeches mentioned, there is also the parallel challenge of adaptation. And to me, there is very little that deliver the information about the urgency of adaptation better than this plot. So this comes from one of our interactive pages, conveniently called Climate Pulse, because the idea is to provide a sense of a pulse to the climate. And what you see in gray are the different anomalies, absolute temperature for the global mean temperature for the last few years. The dashed line is the 91 2020 average. And in yellow, you have the evolution in 2023. And in red, you have the evolution up until 5 days ago. Is a bit more difficult to characterize fully the uncertainty. So for practical reason, you see there is no uncertainty here. It's not that we don't look at the uncertainty, it's just that we decided to project it this way to give a sense of the immediate feeling of what's the climate today. In reality, there is a full quantification of uncertainty and characterization of each data set that are all available and scrutinizable by anyone. But possibly the most comprehensive exercise that we have done in characterizing the state of the climate has been the European State of the Climate Report. So this is now a regular happening. We started, I think, in 2017 or 2018, so a few years back now. And this year, so the last report is the one referring to 2023. was a joint report with the World Meteorological Organization. You can find the full report here, but I just want to mention a few highlights, starting from this, which is the cover page, because the cover page in itself is a nice image, but is also an infographic providing information on how the climate has wormed. Each one of these flowers represent a decade. Each petal represent a year, and the color code represent the warming climate. So this was possible. The entire exercise was possible because of our excellent editorial team, both within ECNWF itself and with WMO, but also because of many contributions from all over Europe and even farther afield. And typically the report is put together between the first meeting is typically before Christmas, so November, December, and by Earth Day in April is published. So everything is compressed in two and a half months of hard work. And in these few weeks, really, we managed to put together a report that in size and in level of scrutiny, I would argue, is similar to a PhD thesis. So really a major undertaking. And in a sense, this is linked to what Piers was mentioning before. And actually, there is an active interface between us and Piers with the aim of combining and ensuring full consistency between all these indicators. But the idea, I mean, we mentioned the greenhouse gases, we mentioned the global temperature. We go a step further, looking, for instance, at the glaciers and the ocean in terms of, well, this is just a cover with some of the parameters, some of the variables. And I will come back with some of those because for me are delivering very strong messages about the situation, especially in Europe. Well, the first one to mention is the global and the European temperature. And maybe something worth mentioning here before COP and before the end of this year is that 2023 was just below the 1.5 mark. It was 148 in our data set. There is a little difference between different data set, but relatively small, 0.02, 0.01 of a degrees. So it was in basically all data set below the 1.5 threshold. Nevertheless, was very close. And this year at present is actually going above, and everyone is now convinced that it will be the new record-breaking year for Europe. And so there is a high chance that 2024 will become the first year with a global mean temperature above 1.5. In a sense, this is a snapshot of what has happened last year, so in 2023, month by month, and maybe something worth highlighting because I think is important to stress these local differences is how unusual Northern Europe was this year, so very warm in the last part of the winter, and then winter 22-23. And then very cold, anomaly cold at the end of the year 23, and then continuing in 24. And it is always, I think, is interesting to have this information because it provides a much richer experience than just a headline message. Talking about extremes and record-breaking temperature makes the headline, and journalists have an appetite for it. But actually, having the data produced regularly and displayed regularly allow to provide much more information, much more details. For instance, you see the differences east-west that have then mirroring what has happened this summer, in summer 24, with the large anomaly in the southwest rather than the southeast. So there is that richness. And one of the elements in terms of adaptation is certainly the summer heat waves that in September, well, in summer 23, hit mostly Central and Western Europe. This year, the story in 24 was more about Eastern Europe, the Balkans, and Greece in particular. But in the year before, it was tilted towards the West. And it's the ability to look at those that makes is an asset in our ability to adapt to a changing climate. Similarly, looking at heat waves and fires, summer 23 was the summer where we've seen the largest forest fire ever experienced in Europe, in Greece. In general was a relatively active season, concentrated in a few regions that were not necessarily the most traditional one. Certainly one feature of 23 was this anomalous heat wave in the North Atlantic that persisted for many months. I was in Ireland actually at the peak of the heat wave with Frank, and at around that time, so late June, we were presenting the State of the Climate report of the year before. The anomaly in the Irish Sea, in some places of the Irish Sea was around 5 degrees. So an extraordinary anomaly, and an anomaly that extended over a significant part of the northern basin. To the point that in many parts of the North Atlantic and the Mediterranean, 2023 at that time reached the warmest temperature ever recorded for that location. And it was remarkably warmer than usual, especially in the southern side at that time, triggering a lot of worries, because that's also the region where many tropical cyclones develop when heating west. In the report, we looked at other elements, not just the pure geophysical variable, and one of the elements has been looking at renewable energy. So we are hearing about the ambition of Europe of carbon reduction and new novel target for it. This means inevitably having a stronger dependency between the energy mix and the variability of climate. So having information, this capacity factor, which is a fraction, which fraction of the installed capacity can actually be delivered or can be expected to be delivered at that time, or has been delivered in this case. And you see that was a relatively good year for Europe, both for wind and to some extent for solar. This contrasted, for instance, on the year before, where we had a wind drought that affected the northwestern part of Europe significantly. We were mentioning heat waves, and heat waves have a very significant impact on us, in particular on our health. So this is a distribution of the most intense heat wave in Europe, and 23 of the 30 most severe heat wave have all occurred since the year 2000. And if we look at the heat-related mortality, so this comes out actually from the Lancet countdown, was included in the State of the Climate report. But you see that the heat-related mortality has gone up significantly by a third or around a third, and has gone up for all European regions, with very few exclusion in the Eastern Balkans. So this is a very strong message, because also linking to what we were saying before and what Piers was presenting in his presentation, this won't stop anytime soon. So the hazard is getting more severe, and we'll need to certainly adapt to more severe heat wave coming. I was mentioning the glaciers because for me this is one of the most visible elements of climate change, and how strong the change, how large the changes are especially in the alpine or in mountainous region in general. And personally, I found incredible that the unit of measure for losses in glacier size are hundreds of cubic kilometers. It's enormous. And even more dramatic to me is the fact that between 2022 and 2023, so in just the space of 2 years, in the Alps, we lost around 10% of the ice volume. As you see on the top right, is not just a peculiarity of the Alps. All mountain ranges, all ice cover areas of Europe are seeing a decline, here presented with the color stripes. The reports really leverage the investment of Europe in Copernicus, in Earth observation, and in the other services. So the Emergency Management Service has information about river flows all over the domain. And especially towards the end of 2023, we got a situation where the river flow in all major rivers in Europe, east to west, north to south, was notably high and very often exceptionally high, leading to widespread flooding in a number of basins. And I mean, getting into flooding is complicated. Flooding depends on it's driven by many causes, but one element that is maybe worth keeping in mind, and there was a reference to rainfall in Piers' talk, is the fact that we do expect, and we actually observing in all continents, an intensification of the most intense precipitation. So while not all flooding depends on the intensity of precipitation, when you have a year of rain falling in 2 days, as it happened in Greece or in Libya, and more recently in Emilia-Romagna, in Slovenia, or in Czechia and Poland, well, then you're bound to see flooding happening, and we need to prepare for it. One of the elements we added also, thanks to the collaboration and interaction with WMO and the National Met Service, is a list of key events that have taken place, this being heat waves, wildfire, drought, flood, and so on. The estimates were estimate of the losses were just based on the International Disaster Database, and were very preliminary. Actually, unfortunately, the losses are expected to be much greater than what we see here. So the key message for me is the fact that we are moving into an uncharted territory. We are already in uncharted territory in terms of temperature. This means that the future won't be similar to what we've seen in the past. And we need to rely on high quality information available publicly and freely to adapt to this new climate. Thank you.
I hope you heard the applause from the room here. I think we will do similar as we did earlier, that we open the room now for questions to Carlo. So use this occasion. I was wondering on the last map that you showed, Carlo. I understand that this is a sort of interactive map. Is it formed in a way that you can actually go in and look at the specific dots and see what it was and where it happened and so on, or is that something that it can further be fostered or encouraged or?
Not yet, not fully, and it's something we are somehow looking into. Also, because one of the new elements in the climate change service is an attribution service, so climate attribution. So the idea, and an ITT was open during the summer, I think it's closed recently, and we are evaluating the different bids. Hopefully we'll be able to start early next year. But the idea of this exercise is to provide enough information a posteriori of an event, adding objective information about that event. So, for instance, whether in that location, in that area, a certain threshold has been, or the threshold observed has been exceeded in the past, how this event rank with one another. So these are objective information, and then maintain, whenever possible, an up-to-date set of information related to recent literature on the driver for this event and what we do expect this driver to do in the future. So I was mentioning the intensity of precipitation. That's a strong and robust finding that is coming and supported by an extensive literature and by IPCC report itself. For instance, on wind, the situation is much more complex, and it's much more difficult to see a trend in the observation or in projection. So maintaining this database will be, and this background information will be part of this attribution service. So not yet, not fully, also because we are linking with the National Met Services to be sure that the local level, the most reliable information normally is held by the national authorities, and we must work with them.
Thank you for filling out that, Carlo, and also in your presentation, it become very apparent that at least the last several years we have had this contrasting situation between Northern Europe and Southern Europe, and of course I live in Norway, and the expression "coolcation" people traveling on vacation where it's cool suddenly appeared in the media and stuff like that. But yeah, we have a question from Frank, I think.
Thanks, Carlo. Really interesting stuff. Just we had a discussion earlier about the temperature, understanding the global temperature record, and I suppose you made a statement there about exceeding 1.5, if I heard you correctly, this year, or we'd likely exceed 1.5. I'm just wondering how to message that in the context of the global goal, and as Peter was saying, keeping hope alive in terms of what we're trying to do globally and at a European and national levels. Just how best do you see us messaging that information, which you will have out there and quite possibly will be in this report as well from this meeting? So, yeah.
Yeah, thank you. I think that's a very important question, because there is a lot of information and misinformation and general discussion about 1.5. So the first element maybe to stress is that a month or a few months, I mean, now we are 14 months in more or less in a row out of the last 15 that were above 1.5, or a year, doesn't mean that we reach the Paris Agreement definition of 1.5. So we don't expect this definition to be, or the 1.5 in the terms of Paris Agreement to be reached immediately. There is some controversy on how we know when this will be reached, some discussion on how this may be reached. But as even Piers was mentioning before, we do all expect this will happen sometime over the next 5 to 10 years. And I think there is very little space to do. We don't have margin for maneuver. We'll reach 1.5 in the terms of the Paris Agreement, and we'll overshoot. I don't think that there is any credible path that will prevent us to avoid that. So the real discussion for me is about what to do after the overshoot, and how quickly can we go back to below 1.5 in the future decades. But my appeal maybe is too strong of a word, but my suggestion would be to be realistic about the fact that 1.5, reaching 1.5 in the terms of the Paris Agreement is basically a given now, and in all likelihood will happen between the late 2020s and early 2030s.
Thank you, Carlo. Yeah, follow up.
Yeah. Hi, Carlo.
Can you just introduce? I know GCOS, is it?
Hi, Carlo. This is Werner Kutsch from ICOS.
ICOS, almost.
I was happy to see that you start mapping also climate action. For example, the photovoltaic and the wind power stuff. I would like to encourage to map more of this and put more of this in your reports, because I think that's quite important that we also see that the glass is at least half full.
Thank you. That's a very, very good point. And we try to provide the information as robustly as we can, and as objectively as we can. And in that sense, we have included some information that go beyond the physical climate, but still remaining quite close to the physical climate in terms of generating the capacity factor for wind or solar or hydropower is still largely to do with the hazard or the physical component. The reason why we didn't step more in the direction of, for instance, socioeconomics or damages is because basically we don't have in-house the know-how or the capability to assess the quality of the information we provide. So in that sense, I mean, now the report is growing in scope. We have such a large base of institution that we work with, that we can consider having institutions that bring in that capability. But certainly for the core data set that we provide access to as part of the report, but in general as a program, we don't plan to go beyond the physical element, because that's where our expertise sits.
I think this also relates quite well into that sort of question I asked you in the start, to sort of challenge the whole audience here and the scientific communities to to look at which kind of parameters and which kind of physical components that actually feeds into solution parts. So thank you for that question, and thanks for the response. And I think we have gone past our time. It was very nice sitting up here and trying to draw. I wish I could draw longer, you know. But next session, I will challenge the facilitator to draw as far as he or she can.
Thanks a lot. Thanks a lot for the great presentations. Thanks to Ole Christian Christel for great moderation. Round of applause, I would say. We can close this first content session.